This is a really long old video, so do feel free to pause at any point, take a break, make some notes, etc. Take a couple screenshots if you need to, but don't hesitate and don't feel like you need to watch the entire thing in one go, guys. You can always stop and start and come back to it. Just make a note of any timings when you do stop and go away for a break and come back. So what was the point of this video? I will tell you. It is to go through the mark scheme for the development section of your NEA, your non-exam assessment. By now you should have completed section A, which is all of your initial research, so your client, your location, your product analysis, etc. You should have a well-written brief by now, an understanding of your specification, your design ideas are all on paper. Now is the point where we take these ideas and we start to improve them through development. We're making changes, and we're making changes to either the aesthetics, the function, the form, the size, whatever it might be. But as well as making changes, we're also going to start looking at how we're going to make this product, how are we actually going to manufacture this product, what materials are we going to use, and why. So I'm going to do a rundown of this, the specification or the mark scheme that you see in front of you. I'm going to read through that and explain what it is, and then I've also got some waggles to show you as well near the end. So let's break it down bit by bit. Excellent justification provided for selection of appropriate materials and components and proposed techniques and processes, demonstrating an excellent understanding of material properties to ensure excellent quality prototypes that are fit for purpose. So what this actually means is when you are talking about your annotations and you're making notes of your prototypes, what you've done and why, don't just state names or processes. Start to justify your reasoning. So for example, if you're suggesting that you're going to be using resin, are you using resin because you need a particular shape to be molded, and the only way you can do that is through doing a pour or a cast? Are you using resin because of the tough material properties that it represents, what it has, because you need your product to be durable and it's going to get knocked around a lot because it's going in and out of the boot of a car? Don't just state things. This is the point where you've got to really justify what you want to do and why, because you're making something for a specific purpose, a specific person, and we need to show excellent subject knowledge. We need to show excellent understanding. And if you're sat there thinking, well, golly, I don't know, grab a textbook, use the internet, BBC Bite Size, whatever resources you have available to you, use them. If you don't have the subject knowledge in your head, start finding that information out through additional little bits of research. Significant complexity or challenge is involved throughout the production of prototypes. The student demonstrates excellent manufacturing skills combined with an excellent understanding of the need for dimensional accuracy and precision. Don't just take the easy route. Do challenge yourself a little bit where you can. Look and investigate at manufacturing methods that maybe you've not done before, but you feel are relevant, because that's the risk. It's all good and well looking at manufacturing processes that you've never done before. So for example, if I go for resin casting, for example, but if you don't actually need anything in your product to be resin casted, so for example, if you're thinking, oh, instead of just using regular old nail components, I might cast my own, do you need to do that? So, you know, do keep it relevant, but perhaps it's something that you've seen on YouTube and you really want to give that a go, and it is entirely relevant. That is fine. We can give that a go. And even if you already know, well, actually, I'm just going to screw it all together. Yeah, that's fine. You can do that at the end, but this is the development stage. This is where we're investigating our manufacturing opportunities, and this is the chance for you to explore through not only digital research but also through prototyping. You don't have to also make an entire model of something. You can make parts of something. So you can make parts of prototypes or models, which I think is really quite helpful and useful, especially if you've got quite a large scale item that you're actually designing. You can just prototype parts of it. If you've also got a design idea where a lot of the manufacturing techniques are replicated or repeated, for your prototyping, you can just do that once. You don't. So for example, if you're making a storage that has lots of different boxes and you want to start making those different boxes to fit a particular prototype you've just made, you don't need to keep making the same box over and over and over again. If they're all the same processes, just make one, make it really well, document that. You don't then have to make 8 more. You know, we've got to think about our timing as well. The student has selected and used appropriate tools, machinery and equipment using CAM where required, and worked with a high level of skill, precision and accuracy to produce their prototypes. You can state and explain what tools you've used and why, but also you need to evidence that you've made good high quality prototypes by taking pictures of them and putting them on your portfolio. And, you know, do take close-ups of certain areas. Maybe not necessarily with just cardboard ones, because with cardboard, you know, we are just cutting it and gluing it together. But when you come to make prototypes with non-cardboard based materials, so such as MDF or acrylic, this is where you can zoom in on some of these close-ups to show, you know, you've shown excellent understanding of this manufacturing technique by not letting there be gaps. You've sealed any gaps or filled in any areas that maybe look imperfect. You've filed the edges so they're beautiful and smooth and you can't see the saw marks. This is your opportunity to show off and add this into your portfolio. And you can also, on your design pages, which, you know, I know you've done by now, but on your design pages, you can actually go back and start suggesting certain tools and equipment that you might want to use and why as well. Shows excellent subject knowledge, but that's only if you've got the time to do that. Prototypes fully address the design brief, satisfying all major points of the specification and take into account all amendments, modifications to their original design proposals as necessary. Don't forget to link back to all your previous research that you have done. It reminds you of not only what you're doing and why, but also it proves you haven't forgotten. You're still on task. You haven't forgotten that client that you originally decided that you were going to make this product for. You haven't forgot the problem that you were originally going to solve. So just make those links back, because we and anybody who marks this stuff, we will say to ourselves, is this actually solving the problem that they first identified back all the way on page 1? So don't forget that and drop in those little annotations of this meets my brief because, or this solves my problem because, my client likes this because. And also, if for whatever reason you have now made a significant change to your original design idea, and that could be anything, literally that could be the size, function, shape, material, whatever. Maybe you've completely adapted, so now it's gone from being a one functioning product to maybe multiple. Maybe you've decided now that it's going to be made in parts. I really don't know. But if you have made a significant change, this is the time to document that change and explain why. Maybe your client circumstances have changed. Maybe you've encountered new limitations that you didn't foresee. This is where we write this stuff down. So anywhere on these pages, wherever you encounter these limitations or these changes, this is where you document that and write it down. Student makes all required modifications to the prototype in a fully considered manner in light of feedback from user trials and third-party feedback, and as a result of testing and evaluation carried out against earlier iterations of the prototype. Feedback, get feedback, write it down. This could be client feedback. You can literally either give your prototype to your client and go, what do you think? You can take pictures of your prototypes and show it to your client and go, what do you think? And then the feedback they give you, write it down, pop it on the page. If you are able to actually give it to them to physically test, what are they? I mean, you can even take a picture and document them actually testing it out. If your product is a really large scale and you're thinking, well, hold on a minute, they can't actually physically test this material. You can give them small samples of materials for them to physically test. You can give them small bits of MDF and ask them, how, you know, are you comfortable with this texture? Would you like a finish applied, etc. So client feedback is really, really important, and we need to make sure that we're consistently adding this in wherever we can. And it does say third party, so if you can't get hold of your client for whatever reason, maybe you can't show them a prototype or a design, you can ask the people around you, your peers, other designers, friends who aren't even part of your subject. It could be anybody. Just ask people, what do you think and why, and write that feedback down, even if it's feedback that you can't actually use. So for example, if someone's suggesting you change the size, or they're suggesting that you give it another function, if you can't do that, reference that. So still write down their feedback, and if little Timmy suggested, actually, do you know what, you should make it 3 times bigger, you can then put that down on your page, your third party feedback from little Timmy, And then add the response of, although I appreciate the feedback, I can't use this as the product must fit a specific size of XYZ, as this is my client's want or need, etc. So even if they give you feedback that you can't actually use, still reference it, still write it down and explain why you can't use it, because it shows at least you've gone out and you've tried, you've given it a go and you've got that feedback. It's not your fault that it's not actually usable, but also you can then use that feedback to help justify what you are doing and why. So if they have given you feedback that you can't use, explain why you can't use it, and that will just further justify that your design idea is not only amazing but also suitable and entirely relevant. In regards to feedback, you can pretty much ask anybody other than your teacher or any kind of teaching support staff, so I.E. technicians, teaching assistants, etc. Peers, other students is absolutely fine, as well as, you know, people at home. Quality assurance is evident throughout, and it is clear where planned quality control checks have been applied throughout the process to ensure consistency and safety. So quality assurance is making sure that you are able to do what you want to do both safely and securely. So I.E. making sure that machines are well maintained, making sure that your materials have been cut to the right size or that you're using the right materials, making sure that you yourself have the right training in order to do the task at hand, etc. All of this is quality assurance. And you can make references to these on your pages in just the form of little annotations. But also when you come to write something called a manufacturing specification, which is a massive document of how you intend to make this product, you will have a column, you will have a column in that table of quality assurance checks, but also quality control checks. How have you checked the overall quality of the product as you're manufacturing it? What faults are you looking out for or expecting to find, and how could you resolve those, etc. But that would all go on your manufacturing specification. So if you're sat there thinking, I've got no clue what that means, you might not be that far into the project yet, and there'll be a completely separate video on what that is and what we add to it and why. Clear evidence throughout the manufacturing process that appropriate health and safety processes have been both considered and employed. So again, you can have a lovely column that states how you're being safe throughout the making process. I'm not too sure if I've got an animation for that one. Oh, I do. Oh yeah. As well as take photos of yourself on your machines. These can also be included on your PowerPoint. So I don't need a photo for every single stage or step. Just one or two, kind of like a little learning journey or a learning log, just to show that you have used your pillar drill with your goggles and your hair tied up and your apron on, etc. Shows you've got that health and safety knowledge. Whew, right, nearly there. The next few slides are all going to be waggles, so what good ones look like, and I want to quickly make reference to this one. So this is from a portfolio, a high grade portfolio. I believe they achieved an A star from their work. You will see that it is really detailed, and they've made consistent references throughout to their brief, their spec, their problems, etc. Now I'm not expecting you to pause the video and read it word for word, because it's going to be really difficult, because without the whole portfolio you might not clearly understand what they've done and why. But what I wanted to show you this page because when you've reached the stage of development, when you've got those initial design ideas sketched out, you've done at least 8 of them, you're starting to make your prototypes, and now you're really starting to think about, right, how am I going to make this bad boy? What manufacturing processes am I going to use? What materials am I going to need? You might find that there are still some areas that you're not entirely sure of. You might want to go back and just do a little bit more research. You might want to do another product analysis to give you some examples or to give you more ideas. Now that you've got a really good idea of what you want to make, you might want to actually start looking at other specific products that have been made in a similar way to give you that inspiration. You might want to go back to your location and make sure that what you're doing is still fitting for that environment. You might want to go back to your client and get a whole page on just client feedback with possible changes to the product. It's entirely up to you. But I wanted to show you this to remind you that you should never stop your research at any particular point. Your research will be consistent throughout. You know, up until that day you hand in your portfolio, you hand in that folder, you will always probably need to do research to better understand what you're doing and why, to make sure that what you are doing is the most successful that it can be. So the students' work that we're going to look at, their whole concept was they were creating an additional component that could be added to an IKEA Billy bookcase. The idea being that with this component, this additional thing they're making and attaching to the bookcase, you'll be able to easily access books that are double stacked, so one behind the other. Their client has a lot of books, they read a lot, they read the same books more than once, and it's quite annoying when you have to remove 2 or 3 just to read what's behind them. So that's the concept in a quick bubble. At this point, they had done all of their designing through Sketch. They'd started prototyping, but they went back to their bookcase and went back to test and check that their sizes were accurate. They looked again at the contents and where specific books were to better decide how they could improve their overall design idea. So that's what this page is in front of us. And then we go on to the initial design development ideas. So when we say initial, we're talking about the beginning. This is the beginning stage of our development. So this is where we take one of those ideas that maybe we've prototyped, maybe we haven't yet, and that's absolutely fine, but we're starting to think, how can I prove this through Sketch? So anything that's in our head, we're just jotting it down on paper by redrawing it, making small amendments, drawing those changes, and then getting any of that feedback, which you can see here, client thoughts, which they then linked into their changes. You'll also notice that the student always has a conclusion on each page to explain what they've done and why, just to make sure that all their thought processes and their ideas were documented. You can add a conclusion to these pages if you so wish. It is entirely up to you, but I just wanted to make reference because it is there. So we've got beautiful sketches here. We've got some exploded or part drawings here to magnify certain elements. This, for example, is a magnification of that, as is this one here. They're all in isometric, so they're clear and easy to understand. They also have shown how certain things function. So for example here, they've drawn and identified that this part of their design actually pulls out, shows how you can actually access the books within the product that they're designing. Really beautiful sketches. Here they're talking about their prototypes. So they've made a cardboard model. Brilliant, cardboard, we love a bit of cardboard. They've now evaluated it. They're talking about what's good about it, what's bad about it, how it can be improved. They took the prototype home, they checked it in the bookcase, they've made additional references to other research that they might need to conduct. They've even shown on some of their previous research where this prototype went or where it would go. Absolutely fabulous. They've then drawn and developed this prototype further through Sketch. So they've done the one cardboard prototype, they've now developed it through Sketch initially here, and then on the next slide, this is where they start to develop the manufacturing processes, so how they think they're going to make it. So they've looked at joining methods and systems. They've got an area or an element that slides in and out. That's the function, needs to slide, so they've documented that here. But they've gone from, okay, this is what it's going to look like and this is how it might function, to, right, this is how it's going to function because this is how I'm going to make it. They've looked at dowel joints, they've looked at adding pins to get that movement, they've looked at hinges, so initial components. This is where your development work will take you. So once you've done you've made your changes as much as you can with your prototyping, with your sketching, you're now at an idea of, right, this is definitely the form and function that my product needs to be. The next step is, right, how am I going to make this bad boy? You've got to start thinking about how you're actually going to manufacture it, how you're going to make it, the materials you want to use, and most importantly, why. The techniques you want to use, and most importantly, why. And then finally, CADCAM. CAD, computer aided design, is a really good way to also show specifics in regards to sizes and tolerances. So when you're at that point where you really do have a strong idea of what your final product is going to be, or even if you're not sure, you can use 2D design or SolidWorks or Google SketchUp to start making these suggestions. So for example here, this student has done some varieties of the different kind of, we'll call them grills, but they're actually dividers. They wanted to add some aesthetics to it, so they've shown what they could actually look like all through CAD instead of making the same thing over and over again. They did actually eventually decide to laser cut this honeycomb one as a physical prototype, which they could then test. They've added some specifics in regards to sizes by just taking screenshots of their CAD work and then adding it onto the slide and then talking about it. But we're not just doing it because, you know, it's to tick off a box. We're doing it because this has relevant. This really helped this student to decide the final sizes of their product. It really helped them to decide the final tolerances that they'll need to consider or they'll need to follow whilst manufacturing this product out of their chosen material, which at that time was MDF. So we're not just using CAD to tick off a box, we can use it for its specifics in regards to sizes as well, and identifying those tolerances.